I'm busy getting things set up. 1 second. There we go. All right. Okay, I think the ads are done. Let's go ahead and start. All right. Happy Tuesday. It's a Tuesday morning on my end. I know. Oh, very early, isn't it? Yeah, I figured I have a bit of time in the morning. Why not do some programming? I have about an hour and a half, and then I have to get to be doing other stuff. So let's program a bit. Now, as the title implies, today what we're going to be doing is we're going to be playing with clankers. I know, probably a very heated topic. I know that you have some people who absolutely love them, some people who absolutely hate them. I'm quite indifferent. I know they exist. I know what their function is. That's really about it. So why not give it a try? Why not see how they work or what they do? Hey, maybe it might help me with my programming. Alright, so first things first. What we should do is I should highlight out a roadmap. Let's go ahead and get GIMP up and running. There we go. So yeah, the idea is that this is going to be a roadmap. This is what we want to do with the chatbot, with the Clanker, and then from there we'll see if we can build it out. So if you remember my other project that I'm working on, there you go. So my other project that I'm working on, let's get out the pen. 17 is a bit big. Let's decrease the size a bit. We'll go with 2. There we go. All right. Okay. So, if you remember, in my project... Okay, why did the pen get so big? There we go. Okay. So, if you remember for the project, it should be very simple. I have a bunch of individual pictures. These are individual layers that I want to compile into a single image. And then this needs to be sent to a video buffer. So the idea is that this is going to be a stream of these clips that will all be output. The goal in mind is to build something. Alright, so the goal in mind is to build something where instead of having to create a bunch of videos, I will have a system set up where I'll have a folder of pictures. All those pictures get loaded into memory, and then those pictures in memory will be streamed to a video buffer, as you can see right here. And when I talk, like what I'm doing right now, the software will monitor the software. It will track when I speak, and then it will switch which pictures get loaded. As in, I have a very short 5-frame animation of my character talking. So when we hear a spike in the microphone, then it will play that animation. Because the animation is very short and very quick, I don't think I should have too much of a latency problem. Now, the idle animation, so when my character doesn't move, there you go, you see the tail flick, that randomly happens. Okay, it doesn't actually randomly happen. The way that we have it set it up is that I have a video where the idle is constantly looping, and within that video there happens to be a tail flick. So when I get to a certain point in that idle video, then the tail will flick, especially when I'm not talking. But as you can see here, the way it works, yeah, there's an issue here where when I'm talking and the tail animation can happen at the same time, and you get a big problem. Hey, Janoob, how's it going? Yes, I do plan to revise it. I'm actually building the software right now to do it. The reason why I haven't really switched over is because the software I need to use to do it is a bit of a pain in the butt to mess with. So I figured if I build some new software, then I can just swap things out without any problems. So I'm working on it. But yeah, the tool. So because the animation that I have, which is a tail flip, is only about 11 frames. Okay, it's technically 11 frames. This pushed out to be around 24 frames. Yeah, thank you. It's not easy. It's not easy because it's a lot of drawing and a lot of coding, and I don't usually have a lot of time to do it. But yeah, the other thing is that I would like to have these done at the same time. So because of that, okay. So in other words, these in order to get this set up how I want, what I want to do is I want to set up these different layers, these different components of my image, and these will actually be their own individual sequence of images. So, and this is based off of how long they can be. Some can be super short, and some can be very long. And then these will be running on individual tracks. This will become a lot more complicated if the body is moving around, because the body right now is just a single frame that happens to be being warped. So this right here is actually just being warped to do certain animations. So the general idea is that these will be looping, and when I speak, so let's say that this one right here happens to be the talking. This is the fidget. So as long as these do not overlap, for instance, talking is the mouth, and the fidget happens to be the tail. The tail and the eyes. So as long as these don't overlap, then I can set these on individual loops. So when we hear an audio boost, for instance, here's my audio saying hello, then that will trigger the mouth, so we can then see the mouth start, it doing its yapping. And then for this, because this is on its own separate loop, then for my character, let's draw weird, or I know. Let's see here. Let's actually draw a very brief animation. All right then. So we'll draw a smiley face. There we go. And then when we want him to talk, it'll just be a very simple, something like this. Don't mind the fact that my drawing is pretty bad. But yeah, so here we go. And because this is a stick figure, or because this is these different components are going to be separate, that means that when something happens, like when he's talking, only the mouth is moving. The body doesn't move. And then when I want to insert a fidget, this could just simply be a tail. So let's see here, we'll put a tail right here. And this can simply be a fidget. Let's not do it there. Let's see here. You know what? In order to make this not look so weird, let's instead of trying to draw this as a raccoon, let's because stick figures, it gets very weird. Let's just How about this? We'll make him wiggle his hands. All right. That's a bit too small. All right then. So here's our stick figure. So him talking by himself. And then I'm going to still give him the ears. So that's a separate animation right here. The mouth is on its own separate layer. And then the tail is on its own, or I'll put the hands on its own separate layer. So then you can have him kind of moving his arm around. And because the fact that these are individual layers and they are not connected, they're independent, that means in my program, the mouth and the arm should be moving independently. So when we get to a certain point, like 100 frames in, these will be not in sync, and they just randomly happen. This will give the character a bit more life, and it will also make it so that it doesn't, you don't get this janky animation stuff going on. However, this only works when the different layers are not connected. For instance, if I had the mouth being part of the fidget phase, then there might be an issue. So in other words, we need a dynamic compiler. So let's write that down. We need a dynamic image compiler, which is taking these individual layers as they cycle through and generating ourselves the actual image. This thing right here will go into the video buffer. And we don't know where it will be on these particular frames, so these will be in Python. What I was going to do is these are cycling. So I actually had a pointer. That was going from here to here to here every time I was building a frame. So I would run code which would be called compile. So I ran a function called compile. So we'll call this the animator. So yeah, I ran that. It would then cycle through saying, where are we within our talk? Oh, we're right here, so let's grab it. What about in fidget? Well, fidget, because fidget is in a particular, fidget's in a delay, we didn't actually grab any frames. And then we can simply grab the body. So we grab that one. And then we'll grab the other one, which I don't know. This would have been something else. And then it compiles it and then pushes it off to the video buffer. So it works great when as I said, the body is by itself. But this was the idea behind my animator. It was extremely slow and very clanky, which is why I gave up on writing it in Python. However, since we're going to be messing with a Clanker, maybe we can figure out how to do it here. With this in mind, I've already installed Cursor. So last stream, when I was busy programming, one of the viewers actually recommended, hey, why don't you try Cursor out? The original way that you were using it, which happened to have been, I was taking my questions, telling it to, so let's see here, there should be, so if you go to MS Copilot, it wasn't, pretty much I was using chatbots. You can go here to Microsoft Copilot, and you can ask it to do something like write a loop that counts to 10. And then from here, it will then, actually it wants to verify first. There you go. And then from there, I would like, oh, hey, there. It wrote my code. It gave me exactly what, it's so, I wish they would stop this. Like, for instance, they need to stop telling me, hey, here's some other things. Just give me what I want. Don't waste your clankers. They don't know when to shut up. I think I'm going to have to do that as well. I need to see how talkative Cursor is, but usually when I'm talking to Microsoft, I usually tell it, shut up. I do not want to hear your life story. only answer the question. Write a loop in Java that counts to 10. It still talked. Told you to shut up. There we go. Disobedient AI. I don't want to hear your life story. Just give me the bloody loop. Alright then, so yeah, I was told that this was not the best way to do it. So because of that, try and use a dedicated handler, which happens to be Cursor. So here you go. I installed it. I set up the basic free plan. Let's try and write this animator and see what, and put it in here. So let's see here. Why don't we just start writing? So what do we want? We want to write I want to write this in Zig, because Zig is supposedly going to be the new C++, and I want to learn Zig. So write a Zig. Oh. You know what? Let's go with C++ for now. Write a C++ program that takes a directory of images, compiles the images into a single frame with transparency, and outputs image to a video buffer or active, or to an active window. The image directory is parsed by folders that separate out the different animations for the okay. Write a program that takes directory of images, compiles the images into a single frame with transparency, and outputs to a video buffer. The image directory is parsed by folders that separate out the different the different images based on function and tag. Functions include let's see here. The goal is to build animations based on the data, on the individual. The goal is to build animations and output to the buffer. Folders contain the individual. I wonder if I'm typing too much. Individual layers. Example, body, tail, head, or eyes. And these are compiled into a frame. And let's see here. And the first, the first images are compiled into an individual frame. When the compiler is called, the okay then. Let's see, the layers are incremented to the next image. All layers are not tied So each layer needs to be separately incremented. How about we go with that? Okay then. Let's see here. Let's run this, see if it can start working. And we'll figure this out. Alright, so while that is working, let's go ahead and start working on our end. There we go. So that is running. Let's go ahead and load PyCharm back up. So while that is working, let's go ahead and continue with my code. So originally, this is for the animation builder. So this is for actually making videos. I was looking around and I found out that, let's see here, I found my old code actually, my really, really old code. So let me copy it over. So, ancient code. So yeah, let me go find I found my old code. That's the best way to describe it. So let me go grab it real quick. One sec while I load up my old project. It must be this one. And the answer is no, it's not this one. Okay, where is my code? Oh, it might be this one. Yep, here it is, right here. Perfect. All right, found it. Copy. Let's go ahead and paste it in. So here is my old code that I wrote. This is what I'm currently. Yeah, this code right here is what I'm currently trying to rewrite because it was just a giant mess. And if you look, you can see I have a list of emotions. I have a list of stances. For instance, this is the normal. If you look at my character, I have them. It's like there's normal, which is arms are down. Here's gaming, where I'm holding the controller. And then in pockets, which is casual. At least I call it casual. So, but yeah. And then here are the different emotions. For instance, angry, derp, happy, jolly, sigh, surprised, and to think. I'm changing it now to just because originally, like this stance right here, which I'm calling normal now, was considered happy. Probably because of the smiley face. And this is jolly. This is angry. This happens to be derp. Here's sigh. The head is lowered, and the face isn't very happy. Sigh. This is curious, as in I'm looking, this is think, where I'm looking at the camera. And here's shocked. Here's surprised. So yeah, here's all the different animations. I have my background. I set it to 204. This is RBG. You can't tell from here, but this is supposed to be red, green, blue. And then here are the frames. And then here are where all of the animations are located. Here's my coefficients. And then we just start going again. And you can see I just start building out all of the different stuff. Like here's the set for building. Here's the code for building the set animation. Here's the code for building the talking animation. Here's code for building the idle animation. Why they're all separated is because I had, in my infinite wisdom, I organized the folders to all be different. So because of that, it required very different. Code. I couldn't just reuse the same code. For instance, right here, you can even see the way I'm doing the talking animation is a bit different from the way I'm doing the idle animation, which is right here. And then same thing right here. And then you can see I keep calling where the data is located. Oh, I need to fix my mouse. For some reason, it keeps messing up. So yeah, this code here is garbage. This code here is a massive pile of garbage. And this is what I'm trying to rewrite. But it's good that I found it, because now we can use it as a reference. I can go back in and look at it and use it as a way to, as a kind of a, because this code 100% works. So all I have to do is I need to put my images back into where they need to be located, and then I can run this and it will generate everything for me. And all should be good. However, if I wanted to do something like add in a new thing, like add in a new layer, or if I wanted to, if I want to add in a new layer, that's not possible with this code. If I want to add in a new animation, that's not possible with this code. Because if you look, I actually have a folder up here which I have the emotion list right here, which highlights out the different emotions and then the stanzas. So the code, it'd be very, very rigid. So with that in mind, now that we have our ancient code, actually, let's see, how is Cursor doing? Oh. All right, let's load this up and see. How are you doing? So we're building C++, how it works. All right, so here are our assets. Yeah, that's correct. Independent timelines. Let's see here. Okay, let's actually read this and make sure we understand what's going on. So, creating a project, no sudo available. Use VC package for dependencies and vendor STB stack as Fallout. So we're going to build C++, layer compositor. They're right here. It's on MPA home layer compositor. It loads image folders as independent animation layers. Alpha composites them into one frame. It can show that frame in an X11 window or write to a raw RGBA buffer. All right, nice. How it works. Each subfolder is one layer. Folder name is equal to tag. Layers are drawn bottom to top in alphabetical order. So that's kind of what we were doing as well. And then here you can see frame ones, independent timelines. Each layer keeps its own frame index. Calling compile advances each layer separate with wraparound, then recomposites. All right. So we have compile, advanced layer, composites. All layers plus one, and then advanced layer. That means we'll be calling advanced layer frequently. I guess that's fine. Output modes, window, which is an 11x buffer. A video buffer, which is, here we go, which is an RGBA alpha, and then export as a single image. Run and build. So they're using Python. Wow, wait, they better not be running Python underground because I'm trying to speed this crap up. Let's see here. Interactive window. So build layer composite assets, build layer compositor, no window asset. So this is how you just run it. Okay. Now simple assets are already generated under assets. Body tail. The headless test run. Steps exported. Output. All right then. Let's go to here now. So it claims here that we need to go to assets. Let's go locate that. So we're here. There's VKC package. Let me go ahead and do that. I have a feeling I should have told it where to put the file. There's cursor. All right, let's see here. Where did it told us where exactly it output the file? Here we go. Home MPA layer. Okay. Let's see here. So we need to find the... That should be here then, actually. Because sometimes these directories are different. So we're looking for layer compositor. So there it is, right there. Layer compositor. Here, assets. Okay, then. There's the body. There's a tail. And there's the eyes. So first things first, I'm going to tell it to change. I'm going to change it up. So let's expand this. So expand the assets folder to consist of the following structure. So let's see here. We'll do with costume. Then so costume, emotion, animation type, or animation type, layers. Costume is the top layer. That's, yeah, costume is the top layer. Emotion are the different image sets that change, or emotion are the different image sets that change which animations are being pointed to. Animation are the different components that are called to be put into the buffer. And then layers are as above. The different, okay then, the different components to the image. As an example, for the flow, I'm trying to type and think at the same time. I don't know if this is the case for everybody, but for me, I can read relatively quickly when I'm not speaking, and I can type relatively quickly when I'm not speaking. But when I have to do both at the same time, it becomes extraordinarily slow, to the point where it looks like it's humorously slow. Like it doesn't make sense how slow it can be sometimes. So this is one reason why it's taking a bit of time. Maybe, I don't know, okay, maybe I will write it first and then I will say something. That way we won't be stuck here just listening to me say each individual word. So yeah, give me a moment of, let me give you a moment of silence. So. And I also have to, let me think of the words I want to use. Let's see here. Actually, thinking about it, the structure that I currently have set up, because I want to keep these individually, it might not make sense to. We might want to adjust them. So let me actually rewrite this a bit. It might because I want all of it to be very dynamic, I don't think I can have the folders separate. So let's see here. So I'm going to put this right here. Okay then. So, well, let's... Do you talk? Good then. Okay then. Actually, if we think about it, I'm busy just thinking out loud, maybe. Okay. All right, let me get out my... Again, because we're making something new. Oh, I accidentally drew on the background. Let's reset this back up. Oh, that's too bright. No, get away. Okay. Oh, that's too bright. All right, let's go ahead and make a proper layer. So, I'm trying to think of ways to make this as simple as possible. So if we think about it, I have mouth, tail, eyes, body, and we'll call it like VR. Now, this has, it has 3 frames: shut, open, and wide. Tail has, flick 1 through 10. Then eyes has blink 1 through 10. The body is just a single frame, and then the VR is also a single frame. This is controlled by the mic. These are controlled by a timer. And then these have nothing, because they are, they're single frames. So the idea is that when we speak, this will go through an animation where it will be wide, open, shut. That's the loop. So when I chat, it should run through this sequence. And then as these go, these will run through this sequence when we hit a timer. So when a timer is hit, then we'll go from 1 to 10. Oh, let's make that an actual 0. Now, when we speak, this applies a warp, which is the final step. Which is one reason why in my animation code for building the frames, I want to separate out modifying each individual layer and modifying the composite at the very end, because when I speak, this should be warped, where there's a certain bounce, where this is like this is a big bounce, big bounce, not so big bounce, a big bounce, not so big bounce, and then we're back down again. So I should probably write it in this way, because when I'm not speaking, we should be stuck on the shut frame. So I think that would be a good way to put it. When we speak, we cycle through this again. Otherwise, you stick to the last frame. For this one, we're on a timer, and when the timer hits, you cycle through it. This way, and then again, 10 for 10 is where the tail is not moving. So the tail is back to its default state. So yeah, I think if we do it this way, I don't need to have different things like fidgets or I don't need to have these separated out like fidget or talk or idle. I don't need to have these right here because it's just a case of not moving in the sequence. So with that in mind, let's inform cursor about this. All right, so that means all we need are costume, emotion, layers. That's exactly what we need. So let's see here. That means we don't need this right here. The animation is done, doesn't need to be there. So let's go ahead and redo this. All right, done. Or layer, I should say called layers. Instead of say for other layers, let's say some. Okay, let's do that. So as you can see, what I told it to do is write the. Let's see where. Oh, okay. It's where did the oh. Here it is, right here. So as you can see, what I did was I told it to do that, and actually, because of this, because we're messing with this now, and because we're messing with this now, it kind of makes me feel like I should also take credence to that and start organizing my data as well. So I'm going to go ahead and copy, I guess, this one. Or no, we're going to do layer. So this is going to be the, call this cursor example. We'll call it cursor layer example. We just need the one. So we'll go ahead and move that to trash. So we just need the one emotion too. So this. So originally, the reason why I separated this out was because I had different, well, for instance, fidget involved moving the eyes around and the tail. Talking ended up just moving the mouth. And these are pretty separate. But I did plan later where, for instance, when I talk, maybe the eyebrows might move a little bit. So, the eyes might get activated as well. I might blink while we go through it. It really depends on a couple things. Hey, Exo, how's it going? Yes, I had a little bit of time this morning, so I'm busy playing with clankers. Okay. All right, then. So yeah, so for instance, if you go in here, this is the fidget. If you look, all of them are the same, except for the tail. The tail happens to be the only thing that moves. So let's go ahead and put it right here. And then if we look at the idle animation, it should all have a single frame. Yeah, see, they all have a single frame, so we don't need that. Well, actually, you know what? Since they all have a single frame, let's go ahead and just grab this right now. We can switch these around. Oh. This would actually be a great base. All right, then. So we'll get rid of fidget. We'll get rid of idle. Talking. So the intro, I think that might be where the big problem lies. The intro. So then here, if you look, we have the eyes. We have the... This is the body. I believe this is talking. So yeah, VR eyes right here. And then I believe that might be the only one. Yeah, that's the only one right here, the VR eyes. Let's see here, we'll put this, move the trash. And then from here, we now can get rid of talk. And we'll move this trash. Now, yeah, this is where, I think the reason why I separated it all out. Doing well, doing well. I am, as I said, I'm having fun programming. I'm having fun playing with clankers. Last time on stream, somebody was talking about it, and I thought, hey, it might be fun to give it a try. Let's see here. My original setup of using clankers was not very smart, and because of that, I tended to have very not so good experiences working with it. I could get it to do basic things, but building something, not so much. But now, oh hey, here's the code revisions. We're going to definitely have to go into this and see what's going on. But yeah, this before we check that out, this is where this is probably the reason why I separate them out, is because of intro. If you look at intro, you can see these are all three images. And they look pretty basic. But the thing is, if you go in, you can see the character leans forward. He ducks a little bit. Then he overextends. And then finally at the very end, it's where he needs to be. So the body is changing. However, if you look, the eyes are changing as well because the body is moving. So because of this, yeah, the eyes are moving. And then the VR headset is also moving, if you look. Because I had to draw each of these individually, especially when it comes to the layer, or this, because the intro is a dynamic. it gives the character a little bounce. In fact, if you look, I can even make him headbang because of this dynamic of the intro animation. See? So you can kind of see the intro animation at work. Now, because of that, and the fact that it's all dynamic, how would we separate it out based on the layers? Because if I set it like this, this is why I separated them out originally. It's because of the intro. I mean, I could get rid of that little bounce at the beginning and then just have my character constantly switching between the different poses. But, I mean, it does, like, if I talk right now and I can move him around, it does look pretty, I mean, it feels a bit janky when I do that, doesn't it? Having that little bounce just adds something to the feeling of the character being alive. I mean, if I am going to have him switch between the different animations, I would have to add in a bit more, they're called transition. Oh, actually, maybe? I just thought about transitions, but how would we organize the data like this? I know. Since today is all about clankers, let's go to Microsoft Copilot. Okay. Let's see here. Where are you? Copilot, right here. Okay, then. Let's see here. I need to start a new chat. All right. Only answer the question. Do not. Or okay, maybe let's not do that. I need it to have verbal diarrhea right now. So. All right, let me type the question out. I spelled animation wrong. Let's see here. Okay. All right, let's let this Clanker run. And while that's running, let's get back to cursor and see how, let's see how it has fared. All right, Mr. Clanker, how is it going? What did you say? All right. So we are right here. Here's its to-do list. So there's neutral, body, for yep. So there we. Oh, they have a layer config. Interesting. And there's blink, there's tail, there's hat, and then there's robot. Okay. Each layer has a PNG plus a layer config that defines trigger. Ah, I see. I see. They ended up using a layer config file. All right. So we have microphone, we have timer, static, and step left or right, as in steps to the manual. Okay. Here's an example of the microphone. We have a trigger, frame rate, threshold. What does threshold mean? Yeah, what does threshold? Oh, I get it. It's for the microphone. When you activate the microphone, what the threshold needs to be. Then we have a trigger, which is the timer, frame rate of 10, interval second of 3, and then idle on last frame, which is true. There should be a idle length, how long it stays idle before it. Yeah, there should be an idle length, so how long it takes before it gets to the next it recycles and goes back through. That might be interval in seconds. Every 3 seconds, then it will go back through. Code changes. Layer compositor. We now have it set to costume and motion layers. And then it has supports set costume, set emotion. And it runs update delta to trigger all independently. All right. And then here to run it, you do this code. Let's see here, controls. M is to toggle a simulated microphone. E is to cycle the emotions. C is to cycle costume. And then tabs. Okay, so let's continue. I know that I know I probably should be trying this each step of the way, but I would like to get it set up to something a bit. I want to get it to a bit further down the road before I do that. For instance, cycling costumes and emotions. I want to set that so that I can actually toggle those with a button. Like what I do right now. Right now I have it set up where I can... It's tied to the numpad. For instance, this is one reason why sometimes you might see in chat, you might see a random 6 or a random 8 or a 9 show up. And that's because that's how I tied my character's animation to it. So when he's moving around, it's because I'm constantly pressing on the numpad. For instance, oh, I feel a bit down. That's a 5. Oh, I'm angry. Or I'm derpy. It's a 6. 9, or I'm angry. So you get the idea. I'm pressing the numpad to do this. And this makes it dynamic. It makes it much better than having to cycle through the emotions. So let's write this. Update the code. So that's... Oh, let me just type it and then I'll explain it. I didn't do it the last 2 times, so let me do it this time. Alright then. I like the idea of resetting everything by pushing R. And for the cycling of the costumes, we'll keep that for now. Let's see here. What was the other thing that we want to do? So this set of Like this line here is just to tell it how to change the costume. I'm guessing we're fine with the microphone, and we're fine with the other ones. I'm busy doing a quick peek at the stuff to see if there's something else that I might... How about we focus on the... Alright then. Actually, let's just run that for now. Let's do that, and then we'll start running the code that it built. Let's see here. How is Clanker 2 doing? That's exactly what I did already. That's what I was originally doing. That's my current structure. Yeah, okay. Alright, so apparently it's not going to give me any novel ideas. Apparently it's going to give me everything that we've already thought of. Because if you look, this right here is exactly what I currently have it set up as. Where we had intro, idle, talk, and fidget. And then the idea is that we would switch between them. But because I want to make fidget and talk, I want to combine fidget and talk so that they're very dynamic. And idle is really just when you're not fidgeting or talking, so it's the last frame of their respective animations. It makes sense to, put them all together. This right here, I don't see how this would work. Maybe let's give this some reference. So... let's give it context. Actually, if you think about it, I just remembered a thought that I had earlier. Yeah, this is a thought that I had earlier. I think it was a shower thought, so I should have written it down, but now that we're trying to figure this out, it just reminded me. So the idea was to set up the different, like these layers, but there would be something like intro, and then there would be idle, and then if there was another animation, then we'll call it whatever that would be. I don't know, juggling. And then from there, let's get GIMP out so I can explain it. If you guys have any ideas, if you think this is a dumb idea, by all means, chime in and tell me, hey, I have a better solution for you. It is, this is, projects only get better when you have more voices chiming in to help. But for now, let's see here. So yeah, I have the intro, which has its share frames that are changing. They each have 3 frames. And then here we have the body. We'll just do the 3 basic ones. We have the body, we'll have the tail, and we'll have the face. So originally I was thinking something like this. And then this would then be subs. So idle, idle, and then idle. And because of the fact that the face was the only thing that was changing, then there would be talk, face, and then these would have another new layer. And then when I activate the microphone, because the microphone is a talking animation, it would activate it would switch the face over because there's 2 of them, And then that way, instead of, if you remember the way my animation works is my guy is kind of, he's here, then he gets even lower. You know, something like that. And then he stretches. And then finally there's 4 here, but that's because this frame right here is this as the start or end of the other frame of the idle animation. And I see we are being invaded by a Clanker. 1 second. 1 second. Let's go. Yeah, we're banning him. But we're not just banning, we're reporting too. One second. You know, I should set up a chatbot. There we go. He is removed. Okay, he's not removed yet. There we go. He is removed. All right, there. He's gone. There we go. I probably should set up a chatbot to track, and whenever we see those types of clankers show up, to just immediately delete them and ban them and report them. We could see about setting that up. It's just that that'll just be another process running in the background, and I have so few of these clankers showing up that sometimes it's just easier to deal with the one clanker. I don't know. If we start getting swamped with them, then we'll set up a chatbot for auto banning. But for now, let's get back to this. So yeah, these are these 3 frames. This is the start of the idle animation. So I might want to change it so that the idle, or the idle is the first frame instead of the last. It would make more sense if we did something like that than have it be the last frame. But yeah, with these, and then from here you can see they have a different, we'll draw the different faces. So here's the one face, then because of the fact that he ducked down, then he stretched, and then here's the last face. So by switching it, having the talk here, I could effectively have this again. Something like that. And then simply put this here. Something like that. However, because this is supposed to be dynamic. So these are independent. Let's see here, and then there would also be a, let's see, idle, idle, idle. This is the talking face. And then, for instance, we will then have it the idle, or this would be idle or standing. Well, let's change this to standing. And then these would also have the same thing. So there's idle, which just simply has 1 frame, tail, which also has 1 frame, face, and then talk face. And these just happen to have 5, like so. Let's see here. Let's go ahead and delete these real quick, because this technically only has 1. So this is what this one looks like. All right. Now what we're trying to do is figure out the way to set this up. Now, because this is the start of the this is the start here. This right here, the intro, so technically, this talking animation should be a bit longer, like so. It should have the 5 frames because it can hop pass on any one of those. This is kind of what I was trying to think of originally. So the talking, and the idle face, they're tied together into a single loop. So I can switch between these two. So when a microphone happens, we'd grab from here. When we're idle, we grab from here. As in when we're not talking, we grab from here. When I click the intro, if we're talking, then we will cycle through here and grab the this is where this is where it gets complicated. Yeah, this is where it's going to. I've the way I have it set up with these layers, at least for my character, it should be very simple. There shouldn't be much issue involved with the animation, but yeah, it means that there's going to be an awful lot, because that effectively means yeah, why is the planning phase, this is always the most difficult. Because now that I have it set up like this, because don't forget, these are changing here. These are all changing, which means I have to have a corresponding face. And there's 3 frames. The way my animation works is that there are 3 frames. There's mouth not open, mouth slightly open, and then mouth big and open. So for each of these points here, we will need one of these frames. And then these will need to be tracked here so that when we're going through, we know what the next one should be getting. For instance, if we're here on layer 2 and we are on the, I guess you say the wide talking face, it should grab that one. But if we're here and we are just finishing a talk, as if we're now in the closed mouth, it should be grabbing that one. But because this frame here is at this angle, that means we would have to have, all of these different frames like this. That means that again, this is why it makes it so complicated. How would one organize this? What data structure can we use to organize this? Maybe I wonder, is it even possible to organize something like this? Because this is very dynamic. Let's see what Clankers have what they recommend. Let's see. Oh, I haven't asked it yet. For context, idle are all similar. Let's see here. So let's see here. I mean, how can I explain it to a Clanker if I can't even if we can't even figure it out to explain it? All right. Let's see here. Maybe, how about this? Let's go check out Cursor, and we'll stew on that while we go. So let's go over to Cursor. Let's see here. I thought I told it to run this. Oh, you've hit your usage limit for the day. I see. Okay. Well, that's a... Okay, well, that's a giant pain in the butt. Well, it is free. We are on the free. So let's just go ahead and run the code then. See how things play out. So cd Python script generate sample assets, and then we do cmake build. And then from here, we can then do a live preview. And then here is the mic test without the hardware. Why does it feel like they're both separate? Let's go load the code up. So let's see here. All right then. So I see cat and robot. And then here's happy. And then here we have body, mouth, blink, tail, and hat. Same thing, and then same thing. Let's go ahead and put our buddy in here. There we go. So there, and then there's happy, and then from happy, and then we have the different layers. And then from here, we have our different layers. The only thing is the intro. So yeah, why don't we go ahead and just remove that for now? Here are our different layers. And then you can see here are the different PNGs that make up said layers. There's our eyes. There's the tail. This happens to be the talking animation. And then, if I remember, they said that each of these should have a config, right? Yeah, a layer config. So let's go ahead and set up this config. I wonder if a config would work. So yeah, microphone 0.2 per. All right, yeah, that's good. And if I recall, we should be able to just grab tail. This should just be a. Oh, this is manual. All right. Maybe let's see here. Static. Interesting that they have different. They have 4 frames for a static image. Yeah, we'll find out. We'll find out as we get here. The main thing is that the head is static, the eyes are static, the body is static, and last but not least is the tail. So let's see here. Are there any hats? Is this static? No, this is on a timer. So this is the one we want. Happy tail. Let's go ahead and edit this. Frame rate is, they claim 6. Let's go with, I have 8 frames. Let's go with 8. All right. Interval to happen every 6 seconds. I think that's good. Okay, so there we go. Now then, let's run our code. So how did it recommend us to run it? Most likely it's to load up here. So yeah, let's just copy this code. Paste it here. Paste. All right then. So the first things first. This needs to be, we need the chain. Oh. This needs to be set to hoodie. And we want to set this to happy. There we go. Hoodie, happy, yep, perfect. And then there's the assets. All right, let's go ahead and run this. All right then. And the animation is, oh, hey, the tail flicked. So yeah, I see the tail flicking. I can't tell if it's talking, but hey, the tail is flicking. The tail is flicking and it is not. All right, let's see here. Maybe if I remember. Oh, hey. I get it. That would be the second set of code, wasn't it? The mic simulation. I don't know why it separated them. It's very strange. But with that in mind, let's see here. If I remember, they said it was from bottom to top, right? That means what we want to do is we just want to switch these around. So let's go ahead and do some quick renaming. So this is now AA. This is now ZZ. This is BB. This happens to be YY. And there we go. Okay. Now then, let's rerun this. We already ran our CMake build. And then this one right here. There we go. Hey, I wonder what that is. That dot right there doesn't make sense. That should not be in my image. But anyway. Okay then. So we have him working. Let's... they said M, right? M was to do a microphone test. Okay, okay, let's wait a second. Hey, it's kind of working. It's actually working. Oh, wow. Hey, it's actually working. Now, you know what now, here's the big thing. Now that we have this, let's do something sacrilegious. Sacrilegious to the people out there who like to vibe code. Let's actually go in here. Hey, nothing really. What do you mean it didn't work? No, it didn't. What do you mean? What didn't? There's our beat. Here we go. Microphone inputs. Let's go in here and start checking out the code, actually. So this happens to be in the layer compositor. Nothing really. I see. That's our include. I think it might be SRC. All right then. So let's go in here and check out our frame buffer code. All right. So how is this working? So we have our frame buffer. We're doing algorithm, CMath, string, and then loop. Hey, that's good to hear. Good to be happy. Glad you're feeling well. Let's see, frame buffer. Then here's resizing. So let's here, frame buffer, void frame buffer, void frame buffer. We call frame buffer many? That must be because it's the BBP. Yeah, that must be it. So we're generating frame buffer, then resize, clear, blit overload, blit over, constants, int. So we have there's our source width, our source height, the destination X, destination Y. It does actually, it matters a lot. It really depends on the person, so it's not a definitive number. For instance, There are some people out there who can sleep perfectly fine with 4 hours, while there's others who need 9.5. You really need to know yourself. You really need to know what your body needs. If you wake up and you feel exhausted, as in, oh, I didn't get enough sleep, then you didn't have enough. Now, the body is a bit strange, because if you oversleep, then your body will feel exhausted, like something's wrong. So you need to find that middle ground where when you wake up, you don't feel too exhausted in either, you just don't feel exhausted at all. Oh, okay, let me put on the lab coat so I can explain it. Let me, give me 1 second while I get into there. There we go, in my lab coat. All right, so, yeah, when it comes to sleep, actually, let me draw this out, so this way it'll help explain things a bit more when it comes to sleep. This is something that a lot of people seem to... There's a lot of misconceptions around it. So when you're trying to... here, we'll draw somebody in a bed, right here. So here you go. Here's the person in a bed, and he's sleeping. When it comes to sleep, you have... the brain has a cycle. You'll typically see it with wavelengths. For instance, you'll have the wavelength going down, and then it'll go back up, and at this point when it goes back up, that means you wake up. This is a hormone level. So when you're here, and... oh, my dog is scratching. So when you're here and you get woken up, so let's say we set off a megaphone or something and wake this person up right here, that's not enough sleep. And that could actually cause you a lot of problems. And because of this fact that this is a layer, these are different layers, if you sleep long enough, you'll start going back down again in your brainwave. Oh. So if you wake up, if you get woken up here, then that'll be too much. Oh, that's fine, that's fine. So you have to wake up right here when when your brain wants to wake up. By doing it this way, you'll feel the most refreshed. Now, this is just brain. There are a couple other things. For instance, sleep is extremely complicated. I mean, it is ludicrously complicated. There's also something involving like hormones. So there are hormone levels that change. And they can change in different ways as well. For instance, it really depends on which hormone you're looking at, but you can see them kind of changing like this. And, oh, I hit the wrong button, sorry. But yeah. And because of that, there are some certain hormones. For instance, I'm going to pick one that is very regen and repair. A lot of people are unaware of this, but these two functions here, regeneration and repair, they happen during your sleep cycle. When people say that if you feel like you've grown an inch, this is very common when it comes for like teenagers, where they say, oh, I went to sleep and then it feels like I grew 2 inches. And that's because you probably actually did grow 2 inches when you were sleeping. And that's because this regeneration repair happens during your sleep. So when you're unconscious, your body will acknowledge like, oh, this person is sleeping. Let's start ramping up all of the hormones and all of the mechanisms for repair. So you'll end up having repair happening here. Yes, you do. You grow in your sleep. Well, when you're a teenager. Once you're an adult, the thing that happens mostly for us is memory consolidation. So this is one reason why I wanted to pick regen repair. But if we go back to the brain, there's memory consolidation. And pretty much when you're down here when you're down here, you'll actually have other wave patterns happening, which will end up spiking like this. that kind of do this motion. And this is memory consolidation. It's very, I'm trying to oversimplify it. So I'm trying to oversimplify it a bit, but when you're sleeping, your brain will consolidate. This is one reason why everyone tells you, study, then sleep is much better than study and then straight into a test. And that's because when you're sleeping, your brain has a chance to consolidate what neurons were firing and compile all this data. When does one stop growing? When they so growing is this all puberty thing, and this is because in humans, at least, you have child phase, and then once you get to an adult, then it's the adult phase, and puberty is this transition between here. So it's during this transition where you have maximum growth. And you might think, oh, that just means I should sleep as much as possible. However, because there are so many things tied here, for instance, like memory consolidation, regen and repair, there is growth. These are all tied to the different these different things here. So if you have too little sleep, you inhibit memory, growth, and repair. And if you have too much, you surprisingly also inhibit these as well. So you need to have a right balance. Oh, that's largely because, again, of the memory consolidation step. So to try and not get into as complicated as it is, let's draw a very simple network. So we'll draw these neurons right here. So here are these neurons. I'm going to pick a different color. Let's go with blue or yellow. So let's say I want to, I'm going to do math. Well, doing math requires this firing pattern here. Like that. This firing pattern is math. And how do we train this? Well, you do a lot of math. I mean, this is the idea. You do a lot of these to strengthen this connection as much as possible. And then when you go to sleep, what your brain does is your brain goes, oh, because this network was so strong, these neural connections, we should keep these around. And so the next time when you wake up, these connections will be much stronger. Let's pick a different color. Let's go with green. And let's say this is math. Let's say this right here is, learning a language. That's learning a language. But I was very lazy. I didn't do any learning at all. I just did what I had to for like 5-10 seconds. Well, once you go into sleeping, because of the consolidation phase, the brain will go, oh, the math? Yeah, you put in, these neurons fired an awful lot. They fire so much. We're going to strengthen these. We're going to keep these connections around. As for the learning a language, yeah, this didn't get fired at all. This might have been a fluke. Let's just go ahead and forget this. Let's go ahead and consolidate what's important. So it'll just actively remove this right here. It'll be as if these connections, this firing never happened. So in the next day, oh, these connections were here firing. So when I think of math, these will fire. And when I come up with let's say I want to do more math, but it's going to be in a different field. So when I hit and, whoopsie, let me go ahead and undo that. Here we go. So let's say it's a different set of math, and I end up firing this neuron right here. So you can see actually, let's pick a different color, which is a little easier. So red right here. Okay, it's not that easy, but you get the idea. When we fire this one, because of the fact that this right here is going to be the other another set of math, because it fires and it overlaps with the other connections that were formed, what ends up happening is your brain will fire the yellow path as well as the red path, and you will have an epiphany and go, oh, this might be why this this will be the epiphany where, oh, this might be the solution to my problem. And that's because now that this problem here that you have, it's firing the pathway of the math or the one that you slept on and you can remember. And now that these two are both firing, you can kind of compile that information together and solve a problem. This is it's a very interesting mechanism here, because what it effectively does is as you gain experience, you'll end up having more of this refinement and more of this firing, joint firing, I should say, and it allows you to just start solving problems it allows you to start solving problems. Because if we just had this, I'm going to draw it right here. If we just had this connection right here by itself, we might not actually be able to solve it, because we don't have the other neurons firing that are that information that's needed for doing it. It's a very interesting, this is one reason, as I said, this is why people say study and then sleep is much better than study and take a test, because this way it will consolidate your memories a lot more than doing this. Because once you do this, it's effectively like the green line, where you just it just gets dropped afterwards. This is why people tend to say they, the cramming sessions, all of the knowledge that they picked up, it just drops out of their memory. It's because they didn't allow them time, they didn't allow their brains to consolidate it. But yeah, regeneration requires this, repair requires this, and then studying requires this. Too little inhibits your ability to do the regeneration and such. Too much will cause also problems. There's a strange study that came out that showed that too little sleep. So if you had too little sleep, let me move down over here so we can see the corner. So if you had too little sleep, this would lead to something. This would pretty much lead to Alzheimer's. There's actually other things, but you'll lead to a neurodegenerative disorder. But if you had too much sleep, guess what it would lead to? It would lead to the exact same thing. And for the longest time, a lot of scientists were like, well, why is this happening? Why is there a Goldilocks zone? Why is it that you need to be in this region here? Too little is not good. Too much is not good. And they found out it has something to do with the hormone levels. And this is largely because your body has a timer in it, built into it. It's called the circadian rhythm. So circadian rhythm. This here tells you how long, when you're going to, your sleep cycle. This is what this is. It's a sleep cycle. For some people, it's when the sun rises. So when the sun is coming up. For other people, it's when the sun is all the way out. And then for other people, it's when the moon's coming out. It's very different depending on who you are. But the idea is that once a certain event is hit, this will reset all of these oh, I just forgot what they're called. It resets these here. It resets this so that it'll all be properly synced. And this is different for everybody. But yeah, they found out that it involved your circadian rhythm, and once you get to a certain point, everything is just oh, thank you. Thanks for the compliment. I enjoy learning, so I tend to read up on a lot of stuff. And again, I used to be a neuroscientist. But yeah, once you reset this, the body pretty much says, this is point 0. At this point in the day, you're going to have a spike in a particular hormone. And if you are sleeping during that spike, it could actually cause problems because you're not awake at that time. And this is largely to do with, the body is extremely complicated. People usually like to think of things like the brain being, so here's our brain right here. The brain is separate from the stomach, which happens to be separate from the intestines. Let's see here. The intestine. And then also even the muscles are separate from those. Like even our muscles. I'm going to draw a bicep. These are all just compartmentalized individual components. They have absolutely nothing to do with each other. This is how a large chunk of anatomy and biology is taught. You have your brain, which is all neurons, and that involves with thinking. You have your liver, which is involved in processing, involved in food processing. And you have your digestive system, which is also involved in food processing. Muscles for movement. And they don't communicate with each other, but that is very, very wrong. I wish I was OP. It's just that I spend a lot of time. I spend a lot of my time studying, and it's fun to learn. But yeah, this is very wrong. To think of everything as individual like this is actually very. It doesn't paint the proper picture, because these all actually communicate with each other. The body. If you've ever seen those videos about ants, how an individual ant, we'll draw a line right here. An individual ant here is dumb, but if you have a whole swarm of these guys, a whole swarm of these guys, suddenly you can get super complex behaviors like building bridges and food defense and all these things. This is kind of how it is in the body. If you look at these individually, they have their components, but when you put them together, you start finding out that there's a lot of communication. For instance, the digestive system. It actually informs the brain about what it wants to eat. So if you have a bacteria in your gut, which says pizza, it wants pizza, it will tell the brain, hey, give me pizza. And then the brain will go, I had a thought. I had a light bulb moment. We should get pizza. And then because of that, you'll be thinking, oh, my brain, it was just telling me I should get pizza. But it wasn't your brain telling you. It was the digestive system saying, the gut flora, the bacteria, want pizza. Could you please go find a pizza and get it? Oh yeah, I hit the button again. I need to fix that. So yeah, and the same thing happens with the muscles. For instance, if you do a particular motion over and over and over again, like drawing. So I am running out of space. If you do drawing over and over and over again, these muscles will tell the brain, oi, we have been working our ass off. You need to allocate. You need to start, or remember these motions, or because the neurons, the muscles, we need blood flow. We need a particular thing here. I know that the neurons control the muscle movement, but the muscles will still provide feedback to the neurons and say, hey, we've been working our asses off. Remember this connection. This connection is very important. So, yeah. All of these different parts inform each other. And because of that, this is one reason why if you sleep too much, then your digestive system, which is expecting breakfast, will be sending out hormones and chemicals and such, and they'll be saying, oi, we should be eating right now, but the brain is currently inactive because of the fact that you missed your period in which the neurons were firing. And then the muscles are also going to be, because of the fact that they're being suppressed, that they are going to have a delay in activity, and all of this disruption because you did not wake up at the proper time can result in diseases. And then, as I mentioned earlier, waking up too soon, you inhibit a lot of the pathways like repair, growth, and memory consolidation, which is why this is bad. And I think the big point to get back to, which to kind of step back again, is that this is all based on individuals. So each person has their own, we'll call him 1, and we'll draw a lady right here. So here's lady, here's a 2, and then here we'll draw a raccoon. Oh, okay, maybe we'll draw a, I have no clue what this is. Whatever this is. There you go. Whatever this is, 3. And based off of that, they might have a different sleep cycle. How about yawning, sir? Oh, that's a very complicated one too. Again, it's... Oh, I should change my animation. That's a very complicated one too. But yeah, for them, this person might only need 4 hours of sleep. The lady might need, she might need 6. And this thing probably might need, a very long period, like 14 hours or something. And it's person to person. So find out what your cycle is and just follow it, and it'll be, you'll feel like $1,000 for yawning. Is that a dog? Oh, okay. Maybe we could make this a dog. Here, we'll give him. There you go. He's a dog standing on his. There you go. Yeah, he's a dog standing on his back legs. Okay, for yawning. Yawning is a reflex that is associated with brain activity, particularly when the brain is overactive and there's not enough oxygen. So oxygen is used for metabolism. There's the whole Krebs cycle stuff, which Krebs, ATP, yada yada yada. So let's not get too deep into that. But the main point is you need oxygen for your brain to run. When your brain becomes very active, there will be a depletion in O2 levels. So let's say this is brain activity. This is oxygen levels. This is when you start yawning. I typically find that when I start working on really complex topics and I have to hyper focus, I start yawning a lot because my brain gets extremely active and there's just not enough oxygen. So I start yawning and yeah. Oh, I really need to fix that. And the reason why people tend to yawn when they get closer to the time when they should sleep, it's because of the fact that your body starts winding down. It's starting to decrease. Your respiratory system starts calming down. So your lungs. Let's draw some lungs right here. Activity of your lungs start dropping. But when your lungs activity starts dropping, that means less O2. So that means less oxygen, which also means more yawning, especially if your brain is becoming active. So if your brain, let's draw the brain right here. There's our brain. If the brain activity is active and then respiratory is down, you get yawns. So this is one reason why people tend to yawn a lot when they are tired, because their brain is trying to stay active and everything else is trying to shut down. And when you're trying to hyper focus, you start yawning because your brain is, there's not enough oxygen getting to your brain. Now, when yawning because yawns apparently they can hop from person to person. Yawning to cool the brain down. Well, actually, that would actually be something interesting to look into. I'll have to look into that. Yawning to cool brain. I'll have to look that up. I wonder if that's an old wives' tale or if that might be something else, because when you mention that, I have heard that before. But I'll have to look it up. It's a very curious question. Actually, I do need to hop off. It is about time for me to hop off. So why don't we do a quick Google search and see. Let's see here. Yawning, cool brain down. Oh, that's actually a very common question. Oh, no. I want to be here. Actually, I'm going to go to my best friend. Wow, why is it so bright? I wish they would have dark mode. No, that's fine. It's fun to get distracted sometimes. Let's see here. Cool brain down by yawning. Yawning and thermoregulation. Oh, there's actually a paper. Oh, there's a paper. Again, the body is so complicated. Let's see here. When was this published, this paper? This was in 2008. So we review a growing body of medical psychological evidence indicating that yawning may be a thermoregulatory mechanism, providing compensatory cooling when other previsions fail to operate favorably. Conditions such as multiple sclerosis, migraine headaches, epilepsy, stress and anxiety, and schizophrenia have all been linked to thermoregularity dysfunction and are often associated with instances of atypical yawning. Excessive yawning appears to be symptomatic of conditions that increase brain or core temperature, such as central nervous system damage, sleep deprivation, and serotonin reuptake inhibitors. Yawning is also associated with drowsiness, and subjective ratings of sleepiness are correlated with increases in body temperature. This view of yawning has widespread application for the basic physiological understanding of thermoregulation, as well as for the improved diagnosis of treatment and increases. Actually, you know what? This is actually kind of fun. So this is just the abstract. So if we want to actually go into their research, is this a research? No, this is a review. So this is a review of all of the research that's available. Sadly, it's being hidden. But the fact that this is a review here in psychology and behavior, this actually can help us inform us a bit more on our current, the understanding that I was explaining. Because if you remember, I'm talking about increases in brain activity. Well, increases in brain activity means increases in ATP usage and production, which is also an indicator of heat increase. They say that a brain that is more active tends to run hotter than a brain that is not active. So it makes a lot of sense then that when you are, it's fun because yawning is also a way of uptaking more oxygen. So there's actually quite a lot of, again, I will have to look more into this because yawning is used for increasing O2 levels. So O2 levels go up when you yawn. And apparently it's also used as cooling, so heat go down. I wonder what else it might do. But yeah, if you have any questions, usually when I have questions, I do exactly what I just did. All right, sorry, it's going to go back to the white screen real quick. I go to Google Scholar, and then I start typing in kind of my question or, the key terms. And then from there, I start looking for papers because this is the direct evidence, the direct research that goes into these things. It's not being filtered through a website or through, somebody else's lens. You go here and you get exactly and then you can make your own decisions about it. In this case, there's a variety of different papers all talking about yawning and cooling, about yawn and oxygen uptake. See, here we go. Here's a bunch of papers about lower oxygen demand and such. So in other words, see, we have now 2 here. Oh, look here. They even come up with a new one. Cerebral blood flow. So apparently yawning might also have impacts on blood circulation. So this was also 2008. Interesting. Wait, was 2008 a good year in research on yawning? But yeah. So you can, from here you can see this is what I like to do. I like to go in here and look at all of the different papers that come out, because if you go to just Google, actually let's not use Google, let's use DuckDuckGo and go yawning. Most likely what you're going to do is get a oh wow, actually, okay, maybe let's use Google. Like Google has turned into the bad search engine. Let's go use Google. Oh, you're welcome. You're welcome. Again, it's fun to learn. I always like to, when I like to teach people, this is how I usually like to do it, because it's entertaining. I always find it fun to do this. All right, then let's see here. Yawning, decrease temp. And then let's see here. Where are we? Actually, it seems like I managed to get something pretty normal. Where are all of the weird places? I see institutes here and all of the clinics. Okay, maybe we go to 6. Here you go. ABC Los Angeles. Perfect. You go here and then they start talking about, signs of fatigue, of boredom, body thermostat. Like, yeah, they're obviously filtering it here. A study in Arizona found that people yawned almost twice as much in the winter than in the summer. Like, this doesn't tell me crap. Come on, ABC News. You're just giving me such... I mean, like, I'm pretty sure that this is actually their interpretation of the data. So, yeah, this is one reason why I like to go to Scholar, is because this doesn't usually tell you much, and they interpret it their own way. But anyway. It is 10:30 on my end. I need to hop off now. It's been fun hanging out. It's been fun coding. I will continue working with my code, and yeah, we can continue with more sciencey talk later. But yeah, it's been fun. Thanks for hanging out. And you guys have a good one. Oop, my dog is getting active. He's like, oh, he's getting active. He wants to start moving around. Anyway. Laters. And thanks for the questions. Nothing really. It's fun.